Hello students. Today we're going to take a look at the last technique that you'll need to use for factoring trinomials and binomials. And in fact, it's special different types of factorizations. So let's look at section 5.4, which is entitled Special Factorizations. To begin, I'd like to take a look at special types of trinomials. So let's just factor using the techniques we know thus far. Let's factor the first example here, which is the trinomial x squared plus 6x plus 9. Okay? X squared plus 6x plus 9. So, by now you should be pretty good at factoring these types of polynomials. X squared is your lead coefficient. You want to find two numbers that multiply to give you 9. But add to give you 6, and those two numbers would be 3 and 3. In fact, 3 times 3 is 9, 3 plus 3 is 6, and so I can factor this as x plus 3 times x plus 3, and if you notice, you have a double pair. X plus 3 is written twice, so you can also write that x plus 3 squared. So you can either write it x plus 3 times x plus 3, or you can write it as x plus 3 squared. Okay, let's look at the next example now. Let's look at example B. Again, we're going to factor a simple trinomial. This time I want to do x squared minus 14x plus 49, x squared minus 14x plus 49. Again, you want to find two numbers that multiply to give you 49, but add to give you negative 14. And this time, the numbers that will work are negative 7 and negative 7. X minus 7 times x minus 7. Because minus 7 times minus 7 is plus 49, and then minus 7x and minus 7x is minus 14x. Again, you have a double factor, so you can rewrite that as a square, x minus 7 squared. So you can leave this answer or this answer here. So let me box those in. X minus 7 times x minus 7, or x minus 7 squared. Okay? And let's look at one more polynomial like that. Let's look at the polynomial y squared minus 20y plus 100. Y squared minus 20y plus 100. Two numbers that multiply to 100, but will add and combine to give you negative 20. And this time, let's do negative 10, negative 10. Y minus 10 times y minus 10. Check, negative 10 times negative 10 is positive 100. Negative 10y and negative 10y is going to give you negative 20y. And so you can also rewrite that as y minus 10 squared. Okay? And I'll box both of those answers in since they're the same thing and both of those are acceptable. Okay, what you'll notice with this, that, and this example is that in each case you had the same quantity being multiplied by itself. And so you wrote it as a square. This is an example of what's called a binomial square or a perfect trinomial square. And so I actually have the general definition or the general formula for that on font, which I'd like you to take a look at right now. So actually, let's take a look at perfect trinomial squares. Perfect trinomial squares are two forms, either a plus b quantity squared or a minus b quantity squared. And they result from two trinomials, a squared plus 2ab plus b squared, or a squared minus 2ab plus b squared. Let's take a look at how those formulas apply to the examples we did here. Notice here, x squared, x is a square. 9 is also a square. 9 is 3 squared. And notice that 3 times 2 gives me 6. And that's how I know this is a trinomial square. And now let's go down to the next one here. X again is a square. 49 is also a square. It's negative 7 squared. And negative 7, if you double that, you get negative 14. So you know this is a perfect trinomial square. And then we'll look at this example up here. 100. 100 is negative 10 squared. Negative 10, when you double negative 10, you get negative 20, and therefore this too is a trinomial square. Let's take a look at another trinomial square that is kind of like hidden. You can't tell right away. Let me give you the polynomial 4x squared minus 20x plus 25. Okay? 4x squared minus 20x plus 25. If at first you don't recognize that's a trinomial square, that's okay. You can always use some techniques we've already learned to factor this. But let's see why it is a trinomial square. If you take 2x squared, you get 4x squared. If you take 5 squared, you get 25. So this term and this term are both squares. 2x and 5. Let me put 2x and 5. Now, 2x times 5 is 10x. And if you double this, you get 20x. And in fact, actually, that would have to make that a negative 5. Negative 10x doubled would be negative 20x. In either case, that's going to tell you that you want 2x minus 5 times 2x minus 5. And that's the product of that. Now, like I said, it's hard to recognize perfect square trinomials. I don't encourage you to try to memorize that formula. I would just memorize or remember how to solve trinomials with our other techniques. But be aware that this is one type of formula that you can use. Let's spend the rest of the time, though, looking at special formulas that you need to use, and that is formulas for binomials. So for the rest of the time, we're going to work on factoring binomials. Okay, so let's factor each of the following. Here's my first polynomial, number 1. Let's factor the polynomial 8x squared minus 12. 8x squared minus 12. Well, what can you do? The only thing you know how to do so far is to remove a factor. You can take out a greatest common factor from 8 and 12, and in fact that is the number 4. Take out a 4 and you're left with 2x squared minus 3. And is there anything else you can do here? Well, not at this time, not that we know of. You can't factor this any further. So that is the factorization for that first binomial. So when you have a binomial, the first thing you want to do is try to take out the factor, if there's a common factor. Well, let's look at a second binomial. Let's look at the binomial x squared plus 4. X squared plus 4. Is there anything you can take out of this? Well, there's no numbers here with the x squared, and there is no common factor. And in fact, this polynomial is prime. It cannot be factored. Okay? So let's look at another polynomial, another binomial. This time I want to look at x squared, and I'm going to put a highlight here, minus 4. I want to look at x squared minus 4 this time. Okay? Not the plus 4, the minus 4. Now again, is there anything you can take out as far as common factor goes? No. However, this can be factored. And in fact, it can be factored as follows. X minus 2 times x plus 2. And let's check. X times x is x squared. X times 2 is 2x. Minus 2 times x is minus 2x. Minus 2 times 2 is minus 4. 2x and minus 2x cancel each other out. And in fact, you're left with x squared minus 4 when you FOIL this. This is the factorization for this. Because you have a minus sign, this one can be factored. And in fact, this should look familiar. We looked at something like this before. What section was it? This was section 4.4. We looked at something called difference of squares. Let me write that word down first. That's the difference of squares. And in section 4.4, what we were doing was we were taking two polynomials, one that had a minus, one that had a plus, otherwise they looked identical. We multiplied those together and we got a two-term polynomial resulting because the middle two terms canceled. See if that rings a bell. See if you remember that, the formula for difference of squares. Let's actually take a second and pull up that formula on font for you, just to remind you again what that formula looked like. So the formula for difference of squares said a squared minus b squared, that's equal to a plus b, and that should be times a minus b, okay? So actually correct that font, or correct that in your notes. It should be a plus b times a minus b, okay? This is the difference of squares, and how do you know it's a difference of squares problem? Because x is a square, and 4 is also a square. It's 2 squared, and that's how you know it's x minus 2 times x plus 2. Let's look at a couple more of these types right here. Let's take example number 4. So let me erase all these trinomials, get them out of the way. Example number 4, which I want to look at, is as follows. Let's look at x squared minus 9. Again, that sign has to be a negative for this to work. So we have x squared minus 9. X is a square, right? X squared. 9 is also a square. It's 3 squared. Whenever you have a square here and a square there, it's difference of squares, and you can factor this polynomial as follows. X minus 3 times x plus 3. X minus 3 times x plus 3. Okay? Real easy. Real easy. Let's take a look at another example. Let's look at t squared minus 25. Can we factor this? Again, the first thing is t squared. That is a square. The second one is 5 squared. That is also a square. And there's a minus sign here, which allows us to write this as t minus 5 times t plus 5. Okay? And so that's the factorization for that binomial. And let's take a look at another one, a little trickier. Let's take 36z squared minus 1. 36z squared minus 1. Again, is it of the correct form? Is this a square and this a square? Well, this is 6z squared, right? 6z squared. And this one can be written as 1 squared. And so this will in fact factor as 6z minus 1 times 6z plus 1. And that's a difference of squares there. And let's look at one more. Let's look at number 7. Number 7, I want to do a little trickier. Let's do m to the 4th minus 49, m to the fourth minus 49. Is this of the correct form to factor? Yes, it is, because this and this are both squares. Well, let's see. 49, that's 7 squared. So 7 is the number there. The m to the fourth, well, that, if you check with me here, is m squared squared. Right? Power to a power, 2 times 2 is 4. So m squared there is the number being squared for that first term. And so we can factor this. Our first number is m squared, and our second is 7. So we write m squared minus 7 times m squared plus 7. And that's the factorization for m to the fourth minus 49. But let's take a look here. This is a square. Can we factor this binomial any further? Well, no, because 7 is not a square. So you can't do anything else with this one. And can you factor this one? Well, right away, no, because it's a plus sign. And you don't factor binomials with plus signs when you have squares involved. Okay. Okay, so what we've just looked at is pairs of binomials that were of the form difference of squares. There are some more special binomials that can be factored, and they are factored with special formulas. So let's take a look at the first type of polynomial that can be factored. So these are more binomials. So let me just write more binomials. But these are not squares. These are going to involve cubes. So let's look at the example here. Suppose I wanted to factor the polynomial, or the binomial, two-term polynomial, x cubed minus 8. X cubed minus 8. Now this is not a square, but this is a cube. In fact, this is x cubed. 8 is not a square, but 8 is a cube. It's 2 cubed. And in fact, if you get binomials where both of these are cubes, we have a formula that tells us how to factor these. So actually, either look in your book, but I'm going to pull it up on font for you to copy down too. Okay, let's take a look at the formula for difference of two cubes. Okay, difference of cubes says the following. If you have a cubed minus b cubed, you can factor that polynomial as follows. The first term, or the first polynomial, is a minus b, and then the second polynomial will be a squared plus ab plus b squared. Okay? I'm going to write that formula again on the board, okay, because it's an important formula. A cubed minus b cubed is a product of two polynomials, a minus b times a squared plus ab plus b squared. Okay, so I'm just rewriting that formula again, and I'm going to apply that formula to this polynomial. Okay, so let's factor x cubed minus 8. Now, you have to memorize this in order to factor this. There's no getting around it. You need to memorize this. Here we go. So the first thing you want to do is, just like I did, recognize that this is a cube and this is a cubed, because you're going to need those two numbers, x and 2. In fact, x and 2 are your a and your b. They're your a and your b. So wherever you see an a and a b, you're going to replace a with x and b with 2. And this is how I remember it. First thing when you have a difference of cubes is you do the following. You're going to write a two-term polynomial. It's going to be the first term here, which is x, minus, because there's a minus here, and then the second number here that's being cubed, which is 2. So this binomial here is simple. It's just taking this x, taking this 2, and putting the minus in between. Now, to complete the formula, this is what I do. I take this x, and I square it, because the formula says take a squared. I take this number here, and I also square it. 2 squared is 4, and that's what this last term comes from over here. 2 squared here goes over here. So I square the first, and then I square the last. And in fact, this is always a plus sign. It's always a plus sign. And then, for the middle, I take this number times this number right here. A times B, or B times A. And so I'm going to have a 2x. Now, if this is a minus, this becomes a plus. Okay? And in fact, let me just write down one more step here. That's x minus 2 times x squared plus 2x plus 4, because 2 squared is 4. And this is the factorization for x cubed minus 8. I'm not going to take the time now, but in other words, if you were to multiply this polynomial times this polynomial, you would get the result x cubed minus 8 when you were done. Okay? Let's do another one using a difference of cubes, and then I'll show you that there's one more thing like that called the sum of cubes. So let's first of all do one more like this. Okay? Let's do B, example B, which says the following. Let's take 125 t cubed minus 1. 125 t cubed minus 1. This is another difference of cubes. In fact, this is 5t cubed, right? 5 cubed is 125. So this is 5t cubed, and this is 1 cubed. You need the 5t and the 1. So now let's factor this. And to factor this, you take the 5t minus 1, okay? And then you're going to square 5t and square the 1, so we have to make a bigger parentheses this time. Square 5t, so that's 5t squared, which you can also do in your head, 25t squared. Square the 1. And the middle number is 1 times 5t, which is just 5t, and so the result should be 5t minus 1 times 25t squared plus 5t plus 1. And that's the factorization for this. Okay, let's look at one more example, example C, and let's take the following. Let's take a cubed plus 27, okay? Now notice, this time, you have a plus. If these were squares, you wouldn't be able to factor that binomial. However, if you have cubes and a plus, you can factor it. This is an a cubed. This is 3 cubed. This is a plus, and you can factor this. And in fact, we have a formula for this called the sum of cubes formula, which I want to pull up on font really quickly, okay? The sum of cubes formula says a cubed plus b cubed is the a plus b times a squared minus ab plus b squared. Okay? So let's take this example. Let's use that formula and let's factor. To factor a sum of cubes, do this. Again, you take the a and the 3. But this time, there's a plus sign, so we have to put a plus here. Do the same thing we did before. Square the first term, square the last term, And in the middle, you take this times this, which is 3a. But this is the trick right here. If this is a plus, this has to be a minus. Let me just highlight that quickly. If this is a plus, this has to be a minus. And if we look right above, when we were doing the difference of cubes, if we look right above, this one was the minus, and that one had to be the plus. So those two signs are always going to be opposites. Okay? That's the correct factorization for this sum of cubes here. Like I said, when you're doing the sum and difference of cubes, you're going to have to memorize those formulas and apply them to these types of polynomials. So that wraps up section 5.4. The key things to remember are difference of squares, sums of cubes, and differences of cubes. Get those formulas memorized and then have fun factoring.